So today we're going to be going over question 4.25 from the EC 140 textbook. So it's asking you to find a voltage described in the source V0 using the concept of source transformation. So highlighted here are the three current sources we see in parallel with resistances. So for this question, the approach that is best to take is to source transform the current sources first and not the voltage source we see in series with that 2 ohm resistance. And the reason is, since we're asked to find a voltage, the easiest way to do that is to use a law such as KVL. So right here, what we're going to do is, after source transforming these resistances that are parallel with these current sources, we end up with the 9 ohm resistance in series with the voltage source. Be careful with the polarities, ensure that the tip to tail matches up so that the tip of the arrow is the positive polarity of your voltage source. And so it becomes an 18-volt voltage source because we have a 9 ohm resistance paralleled with the 2 amp current source. So simply by Ohm's law, V equals IR is the principle that we apply. Here we see we have a 5 ohm resistance, and now it's in series with a 30-volt voltage source by the same principle because we're doing V equals IR. And just before I forget to mention, that voltage source in series with the 2 ohm resistance is 30 volts in value. So that will remain unchanged. And then we notice that our next basically approach is to transform that last pair of resistance, 4 ohm resistance, with that current source, the 3 amp source. And that becomes a 12-volt source in the direction shown, specifically to account for the direction of that current. The polarity of that voltage has to suit. So now that we know that V0 is along the 2 ohm resistance in this circuit, our next approach will be to apply KVL along the single loop. We have resistors. All of our resistors are in series, and all of our voltage sources are in series. So in that case, we can create a KVL equation at that single loop that we have available and then my approach will be to express these voltage drops across every resistance, assuming they're passive, as the resistance and the current. So we're just expressing the voltage drop in terms of Ohm's law using V equals IR. So our loop is outlined as shown. And now we're going on to apply KVL. So we start off at our 4 ohm resistance is where I'm going to start off. So we're going to express that voltage drop in terms of Ohm's law as the 4 ohm resistance multiplied by the current around this loop 1. Same goes for all the other resistances we see here. So for our 9 ohm resistance, any voltage drop we encounter will be a negative. That's the way that I've defined it to be, is a voltage drop is a positive, voltage rise is a negative. So we see for our 18-volt, 30-volt sources, that's a voltage rise that we see, and for our 12-volt source, we see a voltage drop. So now we're going to solve for I. So what we'll continue to do is solve for I now. And solving this equation, we find that I would equal, just going to get that fixed up. And now we find that our current equals 3.3 amps in the direction of our loop shown. So the actual direction of our current is as shown in this diagram as 3.3 amps in this direction. So based on this, we find V0 equals negative 3.3 amps. Take note very carefully because our current is entering from the negative defined polarity of the V0 voltage that is given in the question. So we get that V0 is negative 6.6 volts because we know our resistor absorbs power. So the actual voltage drop seen across this 2 ohm resistance is switched to be 6.6 volts with a positive in the region of the negative defined for V0. So what we have to do very carefully is watch the direction of our current going through that resistor and the defined polarity of the variable given in the question. So we have to watch the direction of the loop that we've defined our KVL to be in and the polarity of the voltage defined, not the resistance as it will say in a minute. So that should say voltage, not the polarity of the resistance, polarity of the voltage source, or the defined voltage.